Okay, we just spent an entire chapter 11, learning all the different properties and ways to deal with square roots and other radicals, how to convert them back and forth between the radical format and the exponential format. And in chapter 11, we dealt with just the principal or the positive square root. We didn't deal with the negative. And even though we had talked about the fact that when you have a square and you take a square root of it, you really could get positive or negative. Chapter 12 is where we start considering those negatives as well. And that's because in college algebra, when you take the square root of something, you're going to be looking at both the positive value and the negative value. And so now is the time to kind of go ahead and accept that negative, and let's keep going with it. So the square root property simply states that if you have x squared equal a, where a is a real number, then you can square root both sides and you get the plus and minus version of the square root of a. So really the only thing we're adding in with this property is that we also are going to consider the negative. Now, we still can't take the square root of negatives. That comes in whenever we learn complex numbers. But we can think about the fact that square root of 9 is going to give us positive 3 and negative 3. Because positive 3 times positive 3 will give us a positive 9. Negative 3 times negative 3 will give us a positive 9. So there are two solutions to that. And like I said, chapter 11, we only considered the principal or the positive one. Now we're going to consider both. And so we're going to do 3 examples just using this. I know 12.1 says solving quadratics by completing the square, and we're going to get there, but we're going to start simply by using the square root property to solve some of these equations. So, x squared equals 36. If you don't know I would say if you don't know the perfect squares of like 1 to 12, that would be something that's helpful to learn. And what I mean by that is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, so on and so forth. It will speed up your process. So if you want something to practice over the summer, that's something I would practice. But here we have x squared equals 36. So using our square root property, I'm going to square root both sides. When you square root a square, it goes away. So I get x equals, well, what is the square root of 36? What times what gives us 36? 6. So we are going to have both the positive 6 and the negative 6. So I'm going to put plus or minus 6. On Pearson, they give you that option at the bottom, and I believe they accept it. I should have done a problem or two this morning to double check it. Worst case scenario, you actually have to list out 6, negative 6, but I'm 99% sure Pearson's okay with the plus or minus. So for quadratics, which are equations that have a squared in them, a lot of times you do get 2 different answers. And you spend a lot of time in college algebra dealing with quadratics. So for the next one, I'm not going to start by square rooting first. I want to get the item that is squared, or the variable that's squared, by itself. So the first thing I'm going to do is subtract that 10 over, so that I have x squared equals 75. Because my square root property only works when I have something squared equal to something else. Now that I have my x squared term completely isolated, now I can do the square root. Now 75 is not a perfect square. But we just spent a whole chapter on how to simplify these radicals. Is there a perfect square that lives in 75? Like what times what gives me 75? 25 times 3. Yeah, it's like playing with quarters. You have 3 quarters. Each quarter is worth 25. 25 is a perfect square. So you find that x is plus or minus 5, radical 3. We're able to split up our radical inside. 25 is a perfect square. It will give us the plus or minus. And that plus or minus falls out front of the 5 because this 5 is multiplying against the radical 3. The plus or minus doesn't come in between. It goes all the way out front. So some of your answers you're going to get whole numbers, some of them you're just going to get radicals, some of them you can get a combination of both whole numbers and radicals. Questions, clarifications before we do the last example of this. All right, the last one we're going to do looks a little bit different than the other two. Simply because we're going to have something in the set of parentheses squared. And that's okay because that could be representative of x. And we have x squared equals 32. We can still take the square root of both sides even though it's a binomial that's being squared. I have the thing that's being squared completely by itself, so I will start by doing the square root. I don't have to worry about foiling that. I'm just going to worry about taking the square root. Because when I square root the square, I'm left with a minus 5. Then over here, I have plus or minus radical 32. Now again, 32 is not a perfect square. But I bet there's a perfect square in it. Remember, if you're not sure what lives within a number, you can always do a factor tree. It's 2 times 16, and right there I would stop. Because 16 is a perfect square. Now, had I done 4 and 8, then I would have kept branching, and I could have still seen my perfect squares in there, but I found it a little quicker. Square root of 16 is 4. So I get the plus or minus 4 radical 2. But a is not by itself. To get a by itself, I have to add the 5 over, giving me 5 plus or minus 4 radical 2. The 5 does not get added to the 4 because you'll remember from chapter 11 that in order to have like terms with radicals, you have to have the same index and the same radicand. That 5 has no radical at all, so I can't just add it to the radical portion. It's not a like term. I don't know. Did I write that right? Yes, I did. Sorry, I couldn't see over the laptop. So all the stuff from chapter 11 is really going to play into these couple of sections in chapter 12 that we're learning. And all of this really helps with solving our quadratics. Because we're going to deal a lot with radicals. They're not going to want you to give decimal representations. They're going to want you to give simplified radical forms. And so you're going to have to be okay with how do we simplify these as we move forward. Questions, comments, clarifications before we finally start looking at completing the square? All right. First, before we learn the steps of completing the square, let's look at the goal. The goal of completing the square is to get a perfect square trinomial. Perfect square trinomials will factor into kind of like our last problem. This is a minus 5 quantity squared. If I asked you to FOIL that out, you would get a perfect square trinomial. Because what happens is we end up with a minus 5 times a minus 5. It's the same binomial, and that's how we know it's a perfect square trinomial. That's our goal. So this looks a little weird, and I'm going to show you lots of steps to get there. But in order to have a perfect square trinomial, you'll remember that quadratics or trinomials typically look like ax squared plus bx plus c. That's our general format. Well, here, we don't want the a out there. We want it to be all by itself. We're going to keep them a little bit simpler. We're not going to, let me double check that before I stick my foot in the mouth. Yeah, we won't have an a. Try and keep it a little bit simpler. And then our b, what we're going to do in order to figure out our c, because our c is generally not going to work nice for us. So to figure out our b and then our c, we're going to take 1/2 b quantity squared. If this is true, then this factors into a perfect square trinomial every time. So if the b and the c, if c equals 1/2 b quantity squared, then it will factor into a perfect square trinomial. And like I said, most of the quadratics you're given will not be that way. And so we're going to learn some steps to make them perfect square trinomials. And this works, this x squared plus bx plus 1/2 b quantity squared. You may want to write below that this also works when you have x squared minus bx plus 1/2 b quantity squared, and that will equal x minus 1/2 b squared. The sign can be different. But it still works to the same thing. The steps are still going to work. And I'm going to show you an example, not by working the steps, just to kind of show you a perfect square trinomial and show you how the b and the 1/2 b squared actually do function and work there. And then we will actually learn the steps for this process. Don't get overwhelmed by the arrows. X squared plus 8x plus 16, that is a perfect square trinomial. If I took half of 8, that's 4, and I squared it, that does give me 16. The same thing's true for negative 8. If I take half of it, that's negative 4. Negative 4 squared is 16. Both of these are perfect square trinomials. The top one factors into x plus 4 times x plus 4, and the bottom one factors into x minus 4, x minus 4. These are already given in the nice format. I simply show you this so that you can see that the b and the 1/2 b and the 1/2 b squared do work. And if you get a perfect square trinomial here, the factoring becomes really easy as well, because the factoring will always be the x plus 1/2 b. So if b is negative, like if this 1/2 b is negative, then notice it's negative here. If the 1/2 b is positive, then it's positive here. So you don't have to worry about any of that stuff. You don't even have to think through necessarily how to factor it if you know that it's going to be 1/2 b in there. Now, that doesn't mean I don't want you to factor. You factor so much. In Chapter 6, hopefully it's just coming second nature at this point. So what is it that we actually do then to do this completing the square steps? Let me give you another example, and we're going to talk through how this works. X squared plus 10x plus 25. Again, this one's already given in a perfect square. Here's how I can test that. My b is 10. So if I found my 1/2 b, that's 5, and 1/2 b squared is 25, which is what I already have. So that's great. So what does this factor into? It factors into x plus 1/2 b times x plus 1/2 b, which is 5, because that's what our 1/2 b is. So you'll see a lot of times in my notes, and when I work the problems, I actually make this little list to the side where I identify what my b is, then I half it, and then I square it, because that's going to help me, one, to check, do I already have a perfect square? And if I don't, it's going to tell me what I need to do next. And if I do have a perfect square trinomial, I already have what it's going to factor into just by looking at the 1/2 b. Let's put the steps up on here. There are a lot. We're going to work some examples, and you're going to see how this plays out. There's 7 steps. It makes a lot more sense once we actually do it, I promise. So how to solve the quadratic by completing the square. If your a does not equal 1, you have to divide everything, absolutely everything by a, or multiply by its reciprocal so that a is 1. That's what we need to start with. And then we need to rewrite the equation so that our constant is isolated to the right-hand side of our equation, because they're going to give you constants that are not perfect squares. It's just not going to work out. Why? Because they want you to learn how to complete the square. So we're going to move that constant over, and then this is where I usually make my list. I would make my b, 1/2 b, and 1/2 b squared, because I'm going to add 1/2 b squared to both sides of my equation. When I add that 1/2 b squared to both sides of my equation, my left side becomes a perfect square trinomial. And I'm allowed to then make it into a nice factored version of that trinomial. And when I have it in that factored form, remember it's going to look like x plus 1/2 b quantity squared, then I can apply my square root property that we were just doing in order to solve, and then we can check our solutions. Just like with chapter 11, you can get extraneous solutions. You always want to be checking your work, making sure that they actually do work in the problems. Ready to try one? I can't put one up with the steps, so are we okay if I take the steps down? Okay. All right, let's look at a quadratic. We have x squared plus 6x plus 5 equals 0. 5 is definitely not like 1/2 of 6 squared, so I know it's not already a perfect square trinomial. And if it asks you to complete the square, it's not going to be, because they want you to do that. So the first step in completing the square would be dividing by a if we had an a, but there's no a besides 1, so we're good there. So we need to isolate our constant, our term without the x, over to the other side. So I'm going to subtract excuse me, the 5 over to the other side. So I have x squared plus 6x, and then you're going to think I'm weird for this, but if you get in this habit, it saves you having to write it again. I'm going to write plus blank right here. So I'm going to leave a plus blank, I'm going to put it equals, and I'm going to put my minus 5 because I subtracted the 5 over, and then I'm going to put the same plus blank on this side. Why do I do that? Because step 3 in our process is where we're going to take 1/2 b squared and add it to both sides. So I am leaving these blanks and being very deliberate in them being there on both sides so that I don't forget to do that. Because 9 times out of 10, if a student misses one of these problems, it's because they'll put the 1/2 b squared here, and they'll forget to do it over here, and it messes up the whole problem. But if you put those blanks in at this step, then you know, okay, wait a second, I got to fill in both of these, so I can't forget to do it on the right-hand side. That's my personal preference. You totally don't have to do it that way. For me, it's a visual reminder that I have to add to both sides of my equation. It keeps me from making some stupid mistakes. So now, step 3, I'm going to list my b. My b is 6. Then I'm going to figure out what 1/2 b is, which is 3. And then 1/2 b squared would be 3 squared, which is 9. That 9 is what I put in my blanks. Step 4 is where I factor. And you can factor by thinking through how to factor, like, okay, I have x squared plus 6x plus 9. That'll be an x and an x. All my signs are positive. And then what times what will give me 9. That adds up to 6, so that'll be 3 and 3. You can think through that. Or it's going to be x plus 1/2 b. So if 1/2 b is positive, it stays positive. If 1/2 b is negative, it becomes a negative in there. -5 plus 9 is 4. So you get x plus 3 squared equals 4. And you want to write it as your x plus 3 quantity squared, because now we have something squared equal to a whole number. We can square root both sides and use our square root property. So if I square root the left and I square root the right, square root a square will give me x plus 3. And then on the right-hand side, the square root of 4 will give me plus or minus 2. So x equals 3 plus or minus 2. Well, 3 plus 2 is 5. 3 minus 2 is 1. Oops, hold on. That's a -3. You subtract that 3 over. So -3 plus 2 would give me a -1. -3 minus 2 gives me a -5. See, it's the little things. It's always those dang negatives that's going to stump you up. Now, at this point, you would want to check. Make sure that -5 and -1 actually do work in the original problem. And they do. There's me checking the -1, and I get 0 equals 0, which is golden. Here, I'm checking -5, and I get 0 equals 0, so that's golden. So they do both work, and these would be the 2 final solutions for x. When you're solving a quadratic, as you will learn a lot in college algebra, you can get either 2 answers, 1 answer, or no answers. It really depends on the problem. So we isolate our constant to the other side. We add 1/2 b squared to both sides. Then we factor into a perfect square binomial like this, so we can use our square root property to go ahead and completely solve it. Questions or clarifications that I can make before we do another? All right. Switch colors because I know I'm getting lots of blue in here. Trying not to waste a bunch of paper. All right, B. -x squared equals a -3x minus 18. The first thing I noticed about this problem is I have my equations all over the place. I have part of it on the left and part of it on the right. I do have a negative in front of my x squared, which is something I would need to resolve before I could actually do my completing the square steps. So I'm going to choose to add the -x squared over to the right-hand side, because not only does that put everything together, but it also eliminates out that negative in front of it. So that would leave me with nothing on the left-hand side, x squared minus 3x minus 18 on the right-hand side. And if you don't like that the 0 is on the left, honestly, you could write x squared minus 3x minus 18 equals 0. It doesn't change anything at all. So if you like having the equation on the left-hand side and your constant on the right, that's totally fine as well. But at this point, I would try to isolate by adding 18 to both sides, get that constant by itself. And if you're like me and want to do the plus blank, that's where I would do it, is right here. And you can do the plus blank in front of the 18 or after. It doesn't change it. It's just there as a visual reminder that I have to add the 1/2 b quantity squared to both sides. So I'm going to make my list, because b in this case is -3. So 1/2 times b would be -3/2. You can have fractions. Fractions are your friend. And then 1/2 b squared is where I'm taking -3/2 times -3/2, giving me a positive 9/4. That's what goes in my blank, is a 9/4. Now, this is definitely a good example as to why I like having this list over here. Because now when I go to factor this right-hand side into x minus and x minus, I do not want to have to come up with factors of 9/4 that are going to subtract together or add together to give me -3. That's gross. But if I know that this ends up being x plus my 1/2 b, then I know that goes in here is just the 3/2. That's why I like making my little list over to the side. Because then this gives me the x minus 3/2 quantity squared. Now, on my left-hand side, that 18 and 9/4, I do have to figure out how to add those. So a common denominator for that would be 4. So 18 times 4 would give me a 72/4. And that's going to give me 81/4. So I have 81/4 equals x minus 3/2 quantity squared. At this point, I can do my square root property. Even with fractions, you can do this. That's why we spent a whole chapter on how to deal with radicals in chapter 11 before we jumped into doing all of these problems. Square root of square, it goes away, leaving me with x minus 3/2. And then luckily for us, 81 and 4 are both perfect squares. Square root of 81 is 9, and the square root of 4 is 2. So this gives us 9/2. But we have to remember we get both a positive and a negative version. So then to get x completely by itself, I would add the 3/2 over to where I would have 3/2 plus or minus 9/2 equals x. Well, 3 plus 9 would give me 12. 12 divided by 2 is 6. So I'd find that x is 6. And x is, if I had 3 minus 9, that'd give me a -6. -6 divided by 2 would give me a -3. And if you don't like doing that mentally, you are more than welcome to come to the side and say 3/2 minus 9/2 and 3/2 plus 9/2 and work through that. You take as many steps as you need in order to get the correct answer. And again, I will save you the checking work. I checked it. They do both work. Now, on your homework and quizzes, you definitely want to do the checking. So fractions are not a problem, unless they're a problem for you, and hopefully at this stage of the semester they are not. Remember, I cover fractions in my Math 20 class in section 1.3, so there's a very long video there if you need refresher on any of that. Any questions or clarifications? All right, let's do one more. That one was a bit harder simply because it had fractions. But if you remember when things factor, they factor into the x plus the 1/2 b. That helps you not have to figure out those factoring steps yourself. I don't know why I wrote b. It's c. We've already done b. Negative 4x squared plus 8x plus 32 equals 0. Negative 4x squared plus 8x plus 32. So the first issue we encounter is we have an a that is not equal to 1. Our a is negative 4. So we have two options that we can do. We can divide everything by that negative 4, or you can multiply everything by a negative 1/4. That's really doing the exact same process. Just depends on which way your mind likes to see it. I'm going to choose to multiply everything by a negative 1/4, mostly because if I was using lined paper, it saves me a line. Negative 4 times negative 1/4 would give me the 1 that I'm looking for. 8 times negative 1/4 would give me a negative 2. 32 times a negative 1/4 would give me a negative 8. Now I have it set up where my coefficient is a 1. I need to isolate my constant by moving it over to the other side. And again, I'm going to choose to leave the blanks in there so that I don't forget. And I'm going to choose to make my list. B equals negative 2. 1/2 b would be a negative 1. 1/2 b squared would be negative 1 times negative 1, which is a positive 1. So I'm going to put a positive 1 in each of these spots. And then when I factor the left-hand side, it's x plus my 1/2 b, so it would be x minus 1 times x minus 1 equals 9. So I get x minus 1 quantity squared equals 9. Apply your square root property, and you get x minus 1 equals plus or minus 3, because the square root of 9 is plus or minus 3. Add your 1 over. So when x is plus, so 1 plus 3, that means x is 4. Or we have 1 minus 3, which means x is negative 2. Questions, comments, or anything clarifying I can help you with?